Okay, this is Blender 3.6 and I'm going to talk you through XROMM tools for Blender, which I've put together recently. So let's get rid of our default cube. In fact, let's get rid of everything, camera and the light. We're going to go to Preferences, Add-ons, Install, and then select the zip folder that you've downloaded from GitHub and enable it. And when that's done, over here, you'll have an XROMM tab. Now there's XCam, import motion, markers, axes and relative motion, and export data. And you can see that right now at v0.1, the markers and the export data functions they're not implemented yet. They're just text stubs or placeholders. But the other things are working. I plan to implement those going forwards, but for now we've got enough to get in the cameras, the motions, and calculate relative transformations. So let's start off and let's bring in a camera. So I've got the pig feeding data set here. So I've exported this from XMA after tracking it all. So camera calibration file, these are the Maya Cams v2 from XMA and an image sequence. It is an image sequence. Let's call this XCam1. Create XCam, and you'll see that's all there. And if we change to, there we go, our shaded mode, and you can see that that video works perfectly fine. It goes purple outside the frame range at frame 0. So let's go back to frame 1, there we go. And let's bring in the next camera then. So camera 2 calibration file, camera 2 images, and this will take images, all movies, single images, AVIs, MP4, that's all the rest of it. XCam2, create XCam, and there we are. We've got our two X-ray images and our cameras. And so what you might want to do is pull this to the side and this down, and then in our view we can set this camera to XCam1 and this one to XCam2, and then hit your F4. In my case, I'm using my commands, view through local camera, and you'll see we've got the view through the camera, and we don't need the PSDR tools that are in Maya. You just, which one is it? XCam2. If we turn off that camera lock, then we can pan, zoom, and do all the rest of it while maintaining the alignment of everything. So we'll do the same down here, you can see that. So that's great, that's our cameras. The cameras work, they play back properly, lovely stuff. So the next thing we want to do is import some rigid body motion. So let's import through OBJ. We'll have the cranium and the lower jaw. And so there they are. And so we select the cranium, we go to import XYZ or motion data. We select our rigid body transformations that we've exported from XMA Import data to selected object. I will implement in the future importing that data to spheres or new objects. We'll figure that out at the time. And then let's grab the lower jaw. Let's select the lower transformation, import that data, and lo and behold, everything's moving as it should, and it's aligned in these images too. You probably want to make these things transparent, so we'll go to the material editor. Let's give it a material. Let's make our cranium blue and our jaw yellow, just for the heck of it. And then let's select this object, and we want to play with the alpha. Alpha doesn't behave properly in EV as it is, so we need to go to settings. Is it settings? No, sorry, viewport display, blend mode, and we want alpha blend. And from there, we can make that object more or less transparent. And what's cool is it maintains the outline of that object. So if we zoom in on this view, we can see the skull object is quite nicely following the X-rays. And we'll do the same with this. So we need to change our blend mode to alpha blend, and then we can change our alpha. Lovely stuff. So we've got our objects in. You see we've got some weird backface culling bit going on there, so you might want to turn that on like that, and then it'll render properly. Show backface, that's what we want to turn off. There we go. There we are. If you're familiar with Blender, you'll know this. If you're not, it only takes a few minutes of playing around with these settings down here to get the hang of it. But the point is, we've got everything we would have had with Maya for visualization there. So our next step then, we can't do these yet. We can't average CT markers and export them. That will come in a future version. But what we want to do now is create an axis and calculate relative motion between the skull and the cranium and the jaw here. So we're going to create an axis, and we can call this whatever we want. Let's call it jaw axes. And we can create it without locators, which creates an axis that is just a simple axis that you can move around, and you would move this to the joint area somewhere that you're interested in and align it. Or you can create it with locators, and this is directly from the Maya scripts. Same idea. So we have two locators, and the axes will follow that. We've got our axis with locators. So what I'm going to do is I'm going to turn on vertex snap, and then we'll move this one up to here, and we'll grab this one and move it over here. And then we're going to grab the axis itself, and we're just going to rotate it. It can only rotate in this one direction, so that the x-axis is sort of pointing straight down the long axis there. All exactly as you would using Maya tools. I'm not going to go into too much detail about which axes you want where. You should be knowing that if you're dealing with these tools. Right, so then we want to select our axes. Our proximal object, skulls are a bit weird like that, we'll call the cranium proximal and the lower jaw distal. And then you want to get it to where your frame is 0. I will implement a pop-up message for this, but Blender's being a bit funny about pop-up messages at the moment. So I'm going to get that so that the mouth is closed. That's about there. And calculate relative motion. And what it's done is it's duplicated the axes. So there's one attached to the cranium and there's one attached to the lower jaw. And then it's created this new object, which is an empty, called jaw axis data. And that's where the data is for the translations and rotations between, relative translations and rotations between those objects. And we can see that by just going to the graph editor, and there we go. So we've got, there's our rotations, and you can see the main rotation is in Z, opening and closing, and we've got our translations down here. And you can play around with how this looks for you. We can turn off the handles, we can make the lines a bit thicker, and so on. But the point is, we can now get this motion, and then when I get myself in gear, we'll have an easy way to export that too. So yeah, there we go. We've got some of the important data and functions implemented in the Blender XROMM Toolkit. I will add a few more. I don't intend to make this fully feature complete with Maya because I don't use all the tools in Maya. But if there's something you particularly want, you can get in touch. Cool. Thanks.